This podcast is brought to you by the IIEA, sharing ideas, shaping policy.
Good afternoon, everybody. My name is Barry Colfer, and I'm the Director of Research here at the Institute of International and European Affairs in Dublin. I'm delighted to welcome you to this exciting event, this discussion with George Monbiot on how do we feed the world without devouring the planet. It's a real delight to host you, George, albeit remotely in Dublin from your own perch. But just thank you most sincerely for taking the time out of your busy schedule. We're looking forward to a great discussion. Before handing over to George, I'm equally thrilled to introduce the chair for today's discussion, Professor Anna Davies. Anna is Professor of Geography, Environment and Society at Trinity College Dublin, where she leads the Environmental Governance Research Group. A founding member of Future Earth's Knowledge Action Network on Systems of Sustainable Consumption and Production on Future Earth Ireland, Anna examines whose voices, values and visions count when shaping policy and practice in matters of sustainability and how this impacts people and the planet. So coming from a think tank here in Dublin, your research is extremely relevant and important. Anna is a member of the Royal Irish Academy, a fellow of the International Science Council, and Anna currently chairs the Rediscovery Centre in Dublin, Ireland's National Centre for the Circular Economy. George, Anna, thank you so much for being with us, and I hand the floor to you now, Professor Davies.
Thank you. Thank you very much, Barry, and good afternoon, everyone. It's an absolute pleasure to welcome you all to this IIEA webinar. And as Barry said, we're delighted to be joined today by George Monbiot, author, environmental activist and columnist at The Guardian. And George has long been a champion for both people and the planet, including his best-selling books, Feral and Heat, not only identifying the underlying dimensions of our most intractable problems, but also importantly, presenting responses to them. So building on his recent book, Regenesis, George will today be speaking to the critical question of how we feed the world without devouring our planet. And this is a timely topic given the challenges faced globally in relation to persistent hunger, poverty and conflict, as well as the need to rapidly and radically expand climate change mitigation and adaptation efforts to reduce biodiversity loss and to embark on a collective just transition to a more sustainable future. So we have about 20 minutes or so for the presentation, and then we will go to a Q&A with yourselves, the audience. So please do use the Q&A function on your Zoom screen to post questions as they come to you during the talk, adding your name and affiliation, and then I'll endeavour to get through as many as possible in the time we have available. And a quick reminder that today's presentation and Q&A are both on the record. And you can also join the discussion on X, so tag @IIEA if you share posts about the event on social media. So without further ado, I'd like to hand the floor over to George now. Thanks, you're very welcome.
Thank you very much, Anna. Thank you, Barry, and thank you everyone for attending. So we face an extraordinary situation, a situation which in some ways is familiar and in some ways is unprecedented. So I'm 61. I was born in 1963. And at the time, people were predicting catastrophe, not just because I was born then, though they probably would have had good reason to do so. It was because people thought that the world population could simply not be fed. There were too many people and not enough food. Now, at the time, there were 3.2 billion people on Earth. Today, there's 8.1 billion people. And the extraordinary thing is that people are, on average, much better nourished. There's much less hunger, less starvation, less famine today than there was in 1963. And there's been a steady trend in the decline of all those bad things until very recently, which has been pretty consistent in most parts of the world. You still get famines, but they're almost in all cases caused by political issues, largely by conflict, and they're generally much, much smaller than the famines of the past. And the background rate of starvation has also fallen way, way down. It's an extraordinary thing that has happened, and something which we scarcely acknowledge. We just take this miracle for granted. We take the fact that our parents' generation or grandparents' generation, their profound pessimism about how everyone could be fed was misplaced. We just take that for granted. We scarcely acknowledge this remarkable situation. What we're more aware of, and rightly so, is that that miracle came about at a great cost. It came about at a great environmental cost, with massive destruction of habitats, of soil, of water resources, huge greenhouse gas emissions, a whole load of other major environmental problems, pesticide use, fertilizer use, you name it. There's been a huge list of issues associated with that greatly enhanced production. It has also come about with a great social cost. Huge numbers of people displaced from land. There's been a great deal of land grabbing, of consolidation, loads of people losing their footing, losing their employment, and a great sort of consolidation of power within the food chain at the same time. And perhaps most pertinently, and perhaps this is the issue that people are least aware of, is that it's running out of road. We know that Russia's invasion of Ukraine, coming on the heels of the COVID-19 pandemic, had put pressure on food supplies for several parts of the world. But what people are less aware of is that the trend began to turn in 2015, that there'd been a steady decline in chronic hunger all the way from the 1960s to 2015, and then the trend began to turn, and we've seen chronic hunger stats rising significantly ever since. We haven't got anywhere near back to the disastrous situation that pertained when I was born, but it's still a very worrying thing to see that that trend has been reversed. And there's several likely factors behind that. One is environmental shocks, which have been coming more and more frequently, particularly driven by climate breakdown. We now see what's called the whipsaw effect, where a major drought is followed by major floods, followed by a major drought. The steady weather that many parts of the world enjoyed seems to be going. We also see now a phenomenon of flash droughts, very rapidly forming droughts, primarily as a result of rising temperatures, increasing evaporation from the soil, and transpiration from plants, and very rapidly draining the soil of moisture. That is layered on top of the degradation of many key farming resources, particularly soil. And in many parts of the world now, soil degradation has got to the point where it's severely inhibiting yields. But less known than any of that is systemic, a loss of systemic resilience within the food system. The global food system, like the global banking system, is a complex system. It has tipping points. And you can tell when you're getting close to the tipping points when the system begins to flicker, when its output values vary wildly. A bit like the approach to the 2008 financial crisis, when equity values and bond and gilt values began fluctuating very severely. We're seeing a similar thing happening here with the global food system, and this is extremely worrying. We could see systemic collapse of the food system as a result of the system's own dynamics, partly driven by corporate concentration, the loss of diversity, the loss of circuit breakers, regulatory restraints on the system, the loss of firewalls between one part of a system and the other part, as the food system has been globally standardized. All these factors suggest we're in a very constrained and difficult situation, one in which 8 billion, and by the middle of the century, before it starts to decline, probably 9 or 10 billion people will need to be fed, where the global food system is already the primary cause of us breaching planetary boundaries. Our food production is the major cause of habitat destruction, deforestation, wildlife loss, species extinction, soil degradation, water use, land use, and one of the primary causes of water pollution, air pollution, and greenhouse gas emissions. It's pushing us towards planetary tipping points as well as towards its own tipping points. And we have to reconcile these two really, really big and difficult issues: how to make sure everyone is fed without destroying the habitable planet, which ensures that people can be fed. And what you tend to see is that people divide into two camps. There are what you could call the productivists who just are totally focused on food production, on maintaining high levels of production, and forget about the environmental and social impacts of that production. And then there are the environmentalists, or most environmentalists, who are totally focused on the environmental aspects, but completely forget about the productive aspects, that we have to maintain high yields of crops if everyone is going to be fed. I mean, the reason this miracle took place is that there's been a massive increase in productivity per hectare. The great majority of it was driven by an increase in the amount of food that you're able to produce from a given amount of land. A smaller part of it was driven by the expansion of the land area that we use for farming, which of course is extremely destructive to global ecosystems. But luckily that isn't by any means the major factor. The major factor by far has been productivity growth within the farm footprint. Since I was born, the global population has risen by 136%, whereas cereals production has risen by 280%. That's why we're not starving. The great majority of the world's people are not starving anymore, although many are poorly nourished, and there's a whole load of things we could discuss about that. Both things are critically important. We have to maintain the high yields, and we have to reduce the environmental impacts. The holy grail of food production should be high yields with low impacts. But there's half the people talking about high yields and half the people talking about low impacts, and very rarely do they come together. We're talking past each other. We have somehow to integrate these two goals. And unfortunately, high yield, low impact food production is extremely rare. There are one or two people who manage to achieve it. Well, more than one or two, but a few. It's a small handful. It's a very small proportion of our food production. There are plenty of people achieving high yields. There are plenty of people achieving low impacts, but generally the high yields go with high impacts and the low yields go with low impacts. That is the fundamental problem we have to solve. And there are some very interesting ways potentially of solving them. And some reside within farming, and some, I believe, will happen outside of farming. So let's very quickly look at the way that things could go within farming, or should go. I would like to see them go within farming. And I believe that the absolutely critical shift has to be a massive improvement in our understanding and knowledge of the soil. Now, soil is arguably the most important ecosystem on Earth, but many people don't even recognize it as an ecosystem. It's, in fact, one of the most diverse and abundant ecosystems on Earth. More than that, it's a biological structure. It's actually like a coral reef. It's created by the organisms that live in it. The majority of soil carbon is used to make polymers, glues, by microbes, with which they stick together the little particles, and they build this thing that we call soil. Without that carbon and without the microbes turning it into glue and then using that glue to make homes for themselves, soil would not exist. And then out of those little microclusters made by the microbes, the middle-sized creatures in the soil, like microarthropods, little scuttling creatures, they make medium-sized clusters. And then the giants of the soil, like ants and worms, they make larger clusters out of those medium-sized clusters. Soil is fractally scaled. It has the same structure at all levels of magnification. And that creates this remarkable structural resilience, which is what ensures it stays on the land, even when you have major events like floods and droughts, which would just blow it straight off the land if it were the undifferentiated mass that we tend to assume. But beyond that, we know almost nothing about it. It's quite amazing, the depths of our ignorance. It's almost a black box. And sure, it is very difficult to study. It's dark. its function depends on its structure, but the moment you dig a hole, you destroy its structure. You've got really big constraints on studying it, but you also have a massive dearth of money being put into studying it. Here we are spending billions of dollars on the Mars rover program to characterize the surface of that planet, which is actually a really simple surface. It's just covered in regolith. It's very boring because it's not made by life forms, where we understand almost nothing about the surface of our own. It's a crazy misprioritization. And it's my belief that if we do understand more about the soil, then we can quite quickly switch from relying on augmenting soil chemistry to augmenting, or better, using soil biology. Because the common characteristic of people who have managed to achieve this holy grail of high impacts, high yields with low impacts, is that they appear to be tweaking certain aspects of soil biology, particularly the very subtle and extraordinary relationships between plants, bacteria, and fungi. With the bacteria being absolutely critical, their relationship to plants in this zone called the rhizosphere, this thin zone of soil immediately surrounding the root hair. And if you can alter your rotational cycle or change one or two of the factors necessary in exactly the right way, you can make the soil far more productive without having to augment its chemistry. But few people have been able to do this. And what's surprising is that techniques which work very well in some places, such as, for instance, someone I've spent a long time coming backwards and forth visiting, Ian Tolhurst, or Tolly, who farms in South Oxfordshire in the Thames Valley without any inputs at all, except seed and a bit of wood chip, which he gets from the local tree surgeon. Everything else is entirely based within his own farm. No animal manure, no fertilizers, no pesticides, no herbicides. And he's managed to do it by very subtly and cleverly tweaking soil biology at certain points, key points in the rotation. Some people have been able to replicate his methods, other people have not. And we don't know why. We know it's got something to do with the soil. It's something to do with the way soil functions in one place, which can be completely different to the way it functions in another place. But we just don't know enough to be able to universalize his techniques and the techniques of other great pioneers like him. So a crucial aspect of this is we should be pouring billions into characterizing the surface of our own planet, into much better soil science, much more of it, and to make soil science one of our crucial disciplines. You know, it's so neglected. It's such an afterthought in academia. And I think there's an aspect of us which shuns the soil, which sort of sees it as something dirty, something literally and metaphorically beneath us. A friend of mine explains it as saying, well, that's where we get buried. It's about death for us. And so we shut it out of our minds. And of course, it is about death, but it's also about life. Soil is where life and death are recycled more effectively than anywhere else. Now, there are further interventions which can be made in agricultural techniques, which could potentially be really exciting and even perhaps decisive. One of the ones which I'm most intrigued by is the potential switch from annual to perennial grain crops. Now, almost all the grains we grow, and by grains I mean not just cereals, but pulses, basically any mass-produced seed is a grain. Nearly all the grains we grow are from annual plants which live and die within 1 year. Now, annual plants in large numbers are rare in nature. They colonize land after there's been an ecological disaster, such as a volcanic eruption or a landslip or some other event which has killed off all the longer lasting plants, the perennial plants. And annuals are specialists in colonizing the bare ground which results from such a disaster. And they very rapidly colonize it, put loads of energy into the seed, which is why we like them, because the seeds are big and there's lots of them. reproduce as quickly as they can, occupy the ground for as long as they can until the perennials come back in and shade them out and crowd them out. And in order to grow our crops, we have to create an ecological disaster every year. We have to clear the land of everything that's lived there before, either by ploughing it or by spraying it, and in both cases with a very high ecological cost. And then we have to start from scratch, planting our seeds and cosseting them, looking after them as well as we can with the help of irrigation, fertilizer, pesticides, herbicides, all the rest of it to favor those particular species. And as they grow, you have to keep feeding them. And then a few months later, you've harvested them and you start the whole process all over again. And it's unsurprising that we see the steady degradation of soil, we see the overuse of water, we see the devastating impacts of pesticides, we see 50 to 80% of all fertilizers being wasted, getting into the wider environment, causing eutrophication in rivers and dead zones at sea, etc., etc. This very destructive, but currently necessary form of food production. But if we could switch successfully to perennial crops, crops which can stay in the ground for years at a time and where you keep harvesting from the same plants, and if we can get similar yields from those perennial crops, we could greatly reduce the amount of environmental damage we're doing. And I've been talking a lot over the last few years with an organization called the Land Institute based in Salina, Kansas, which is it's a bit of a narrowly funded organization. It's an NGO trying to do what should be the work of governments, but it's doing it very successfully. It's scanned thousands of potential plants for their food potential, their perennial plants, and it's either been trying to improve that through breeding or it's been hybridizing, and it's had some standout successes. The best of which is a rice variety, which is developed with Yunnan University in China, which has got the same yields as annual short grain rice, but the plants stay in the ground, the perennial plants, for, well, so far 6 or 7 years, still producing that same yield. And that's led to a massive reduction in soil erosion, a massive reduction in farm inputs, and what makes it particularly attractive to farmers in southern China is that it needs less labor, and there's been a massive labor shortage there as so many of the young people have moved to the cities. And so already many thousands of hectares have been devoted to this new rice variety, and farmers are desperate for the seed because they can save so much money as well as so much environmental damage while still producing the same amount of food. Now that is a very clear example of production hitting that sweet spot of high yields and low impact. So the Land Institute is working with many different candidate grains to see if those can be rolled out as well. Some of them grow very well but have fairly low yields. Some of them have high yields but don't grow very well. So there's obviously a lot of work to do. And again, there should be a lot more funding for that kind of work. But while it's essential that we revolutionize agriculture, I also believe that there are some crucial aspects of food production which should no longer rely on agriculture. And one of those is the protein sources which currently come from animal farming. The harsh truth is that there is simply no good way of feeding everyone on animal products. It's just too environmentally costly. Intensive animal production is an absolute disaster in terms of food consumption, pollution from manure, etc., etc. Extensive animal production, pastured meat, is an even bigger disaster because of its huge hunger for land. Agricultural sprawl, the use of large amounts of land to produce small amounts of food, is driven overwhelmingly by grazing livestock. And that has a huge ecological opportunity cost, which is the cost of not having the ecosystems which would otherwise be there if the land weren't occupied by ranches, but also a carbon opportunity cost, because those wild ecosystems are invariably richer in carbon than the farmed ecosystems that replace them. We should be trying to minimize our land footprint, among other crucial environmental objectives. In fact, land is the metric which environmentalists should be far more focused on. We tend to neglect it in everything except urban land. We talk about urban sprawl, but agricultural sprawl is a far greater threat to the world's ecosystems. So can we take a portion of food production, ideally that portion currently supplied by animal farming, out of farming altogether? If we can, I believe it'll make the biggest contribution of all, because it will allow us to retire large amounts of land from agriculture and rewild it. And in doing so, to restore global ecosystems, to draw down a large amount of carbon, and potentially to stop the sixth great extinction. I mean, I think now a mass rewilding program is the only thing that really stands between us and Earth system's collapse. And as it happens, and we're very fortunate in this respect, the technologies which can do this for us are maturing very rapidly. And the most exciting, promising of them all is what's called precision fermentation, which is the multiplication of microbes in vats. We've been doing fermentation for many thousands of years. We eat loads of fermentation products. In fact, we eat quite a few precision fermentation products. But what we haven't been eating until now is products which are largely composed of the microbes which have been multiplied through precision fermentation. And some of these microbes have extremely high food values, protein content, 65%, all the essential amino acids, generally very good in nutritional terms, and can be produced with much less land, much less water, much less in the way of pesticides, fertilizers, all the rest of it, and in contained systems where the outputs don't spill out into the wider environment as farm systems do. Many environmentalists are horrified by this prospect. I don't want to eat bugs, I don't want to eat microbes, but I think we need to set aside some of our gut feelings, which are understandable when it comes to food, but we need to engage our minds a bit more on this problem and recognize that just as we can't solve the problem of climate breakdown without replacing our energy supplies, without solar, without wind, without other environmental technologies, we also need new environmental technologies to solve a problem which is just as big as that, which is the multiple impacts on Earth systems caused by our food supply. Now, of course, it's not just about technology. We need political change. We need economic change. We need social change. We need cultural change, all of those things. But without the technology, without the technological change, all those things become much, much harder. It's as if we were saying to people, cut your emissions, but there are no alternatives to fossil fuels. You'll have to cut your emissions while using only fossil fuels. I think we need to get past that. We need to get past our instinctive revulsion towards new food technologies and understand that some of them could be extremely beneficial to us. Thank you.
This podcast is brought to you by the IIEA, sharing ideas, shaping policy.